Okay, our problem statement for this program is to create a program that accepts one number as input and determines if the number is prime or not prime. So the first thing we need to do is make sure we understand what the problem is. So we need to look at what is a prime number. And so we'll look at the definition as a whole number greater than 1 whose factors are 1 and that number itself. So let's take a look at our code. And so what we'll do in our code is we need a couple of variables here. Since we need to input a number, let's create a variable. We'll create a long integer. Matter of fact, we'll create a long integer. That way we can accept very large numbers as input, and we'll just call it number. Okay, so we'll have a long integer called number. We'll go ahead and initialize it to 0, and then we'll have a Boolean variable, and we're going to call it is prime, and we're going to check to see, if the number is prime. During the course of the problem, we will prove it's not, then we'll set it to false. So initially we're going to assume that it is prime, so we're going to set is prime to true, and if we can't prove that it's not prime, then it will be prime. Otherwise we'll reset that value by the end. Okay, so first thing we need to do is get input. So first thing we'll do is use a friendly prompt to say, hey, enter a number to check, and then we'll cin, and remember our variable is just called number, so we'll cin number. Okay, and now we need to set up a loop to go through every number between 1 and that number itself to make sure it's not evenly divisible, okay, by all those numbers in between. So we're trying to make sure there are no other factors other than 1 and the number. Okay, so we'll set up a for loop, and so we're actually going to start that loop not at 0, not at 1. This time we're checking all the numbers between 1 and the number we're checking to be prime. So we're actually going to start checking at 2. And remember, the data type is long, so we need to make sure that matches so we can check up to that number value. So again, we're going to initialize our variable equal to 2, and then where are we going to stop? Okay, well, we're going to stop before we get to the number they entered. So we'll check as long as I is less than number. Okay, so in other words, less than is going to stop just short of number. If we put less than or equal to, that would include the number. That would throw our results off, right? It would say everything's prime, so that would not be right. So I less than number, and we're going to, at least for now, we're going to get there by 1, so we'll do the old I plus plus thing, and that's our for loop to go through all these numbers. So let's add the actual loop itself, and what we're going to do is put an if statement in here to say if. Okay, now how do we check to see if it's evenly divisible by any of these numbers, like, in other words, 2 up until 1 less than whatever the number we're checking is? Well, we're going to check number mod. Remember, mod is integer division, but it gives you the remainder of integer division, right? So we're going to mod I as we're going through the loop. So the first time through, we're going to mod 2, and we're going to check to see if it's equivalent to, okay, remember this is the remainder, so what are we looking for? Okay, that's right, we're looking for 0. In other words, if we get 0 remainder, it was evenly divisible by one of those numbers from 2 up until 1 less than our max number there that we're looking to see if it's prime. So if we see a remainder of 0 from 2 to 1 less than that number, we know what? It's not prime, right? There's other factors in there. So we're going to go ahead and say, well, if that's true, we're going to set that is prime Boolean value to false. So we've just proved it false. Now, if we wanted to kind of, I guess, make this efficient, we could put in a break statement here to say, hey, break out of this loop because as soon as you prove it false the first time, you really don't need to do that. But I want to do optimizations a little bit later, so I'm going to leave that as a comment statement. Okay, so that pretty much sets up the major logic for our thing. So if we prove it false, it's going to be false for the rest of the loop, even if we check other things. If it goes through here and it checks everything between 2 and less than that number, and it never proves it false, then it must be true. Okay, so all we need to really do is add our output statements at the end of the loop to say, well, if is prime, which is our indicator, and remember it's true or false, so we don't need to put the equal here. So if it's true, then we're going to see out that number that they put in is prime. Otherwise, we can output that number is not prime. So if it's true, we output the number is prime. If it's otherwise it's false, we put the number is not prime. Okay, so let's check this out and see how it works. We'll go up and execute, compile and run. And let's test some numbers we know. So what are some numbers we know to be prime? Well, if we look them up and we find some of these, here are a few numbers that we know are prime. So we could test out 2, 3, and 5. So let's go back to here and we'll go ahead and put in 2. And notice 2 is prime. And we'll go ahead and hit enter key on that. And we'll run it one more time here, compile and run. And let's put in 3, and it finds that is prime. So it seems to be working. Only other thing we might do here is put in a few things for error checking to make sure they're actually entering a number. So remember, we can do the if not cn, then we have invalid input. So we're just going to output a message, and then we can return 1. Okay, so we're going to return an error message. The other thing we can do, we're kind of expecting with our loop that we're going to get a number 2 or higher. So we can check for other numbers and say, well, if the number is less than or equal to 1, by definition, that one is what? Not prime. So we're going to set is prime to false, and we'll put an else. So if it is false, we're just going to do this part. Else, we need to check all this other stuff, right? We need to do the for loop. So we're just going to put that between our else statement here. So else, if it's not 1 or less, we're going to check all this stuff we had before. And then we're still going to have our is prime here, right? So let's check that. We'll compile and run it. And let's put in 1. And it'll tell us 1 is not prime. Okay, so that's our first stab at our program to see if a number is prime or not. There are some things we can do to improve this, but we'll save that for next time.